Assalamualaikum and hi everyone. So today we'll discuss about our final topic in BJT, which is transistor as a switch. Okay, previously we already learned about transistor as an amplifier. Okay, so to operate as an amplifier, the transistor must operate in active region here. Okay, so this is an active region. Okay. However, to operate as a switch, the transistor must operate in cut-off and saturation region. Okay. So this is saturation region. Okay. And this is cut-off region. Okay. Okay, for transistor to operate as a switch, there are two conditions that we need to consider here, cut-off and saturation. Okay, so let's talk about cut-off region first. So the transistor is in cut-off region when the BE junction, this is BE junction, is not forward biased. Okay, so as the base region is open here, this is base region is open. Okay, so the BE junction is reverse bias. Okay, so there is an open condition between the collector and emitter here. Thus, the current cannot flow. All currents will be zero. Either it is IC or IB, all are zero. And this condition can be illustrated in this figure here by the switch equivalent here. Okay, so the transistor is fully off or in cut-off region. Okay, so now we can say that the transistor operates as an open switch. Okay, and then since the current is zero, so the VCE cut-off equals to VCC. Okay, the transistor is in saturation when the BE and BC junction are forward biased. Okay, so this is BE junction and this is BC junction. Okay, so how can it be forward biased? Because this is plus VCC and this is plus VBB. Before this, for the cut-off, there is no input voltage for the VBB. Okay, but now we have an input voltage of VBB at the base here. Okay, so when the BE is forward biased, there is enough base current or IB here to produce a maximum IC. Okay, so now the transistor will be saturated or fully on, and this will be illustrated using an equivalent switch here. Okay, so now this is a closed switch. Okay, and the formula for collector current is given by this formula. Okay, so VCE minus VCE saturation over RC. Okay, but then since VCE is VCE set here, since the VCE saturation is very small, so it normally can be ignored. Okay, and the minimum value of the base current or IB to produce the saturation is given by this formula, where IB min equals to IC saturation over DC beta. Okay, and the IB, the base current, should be greater than the minimum base current for saturation. Okay. Okay, now let's see how can we use the transistor to turn on or to turn off the LED. Okay, so here we have the LED. Okay, so let's apply a square wave input voltage with a period of 2 seconds here. Okay, so 1 second to turn on and 1 second to turn off. Okay, so when the input is 0, okay, when we give 0 input here, the BE junction will be reverse biased, therefore no IC a collector current can flow here, okay, since it is open between the collector and emitter. Okay, so this is open when input or VBB is 0. Okay, so LED will be off. Alright, then when we give 1 here, okay, when we give 1 or when the square wave input goes high, the transistor is now saturated as the BE and BC are now forward biased. Okay, so now LED is also forward biased and the IC, a collector current can flow through the LED here, and the LED will emit the light. Okay, so that's how we can use a transistor as a switch that can turn on or turn off the LED. Okay, so that's all for our chapter 4 or BJT. Thank you for watching. Please stay safe and till we meet again. Assalamualaikum warahmatullahi wabarakatuh.